Hi everyone, welcome to another tutorial about variable length subnet masking. Here we are going to look at why fixed length subnet mask wastes addresses, what is variable length subnet masking, and we'll look at a case study of a company which has different departments with different number of hosts that need to perform subnetting on their account. So let us move forward and we try to look at variable length subnet masking. Now, previously we looked at fixed length subnet masking, and we said that when we are looking at FLSM, every network, every subnet we create is of the same size. And that means that if we have departments that need different number of hosts, the same large subnet is given to all of them. In the previous example, you saw that we created 4 departments, and all those 4 networks were having a total of 64 host addresses. Even small ones, for example, you have a CEO's office which only has 2 or 3 computers, but we are wasting 64 host addresses on them. So the leftover addresses in a small department subnet sit there unused and wasted, like the example we looked at. We have, for example, here the different departments. We have the finance department, which has a total of 55 used. So we have 7 addresses unused. We have the library here. We have assigned 30. We have 32 unused because everyone is getting 62 host addresses. And in a small department like a clerk's office where there are only 5 computers, 57 addresses are wasted. So we are literally wasting about 148 addresses out of the 254 addresses available. Over half of the entire network is thrown away, and that is where variable length subnet masking comes in. It comes in to particularly solve this problem. Here in variable length subnet masking, each subnet gets a different size of the subnet mask based on how many hosts it actually needs. So a larger department gets a larger subnet, and a small one gets a small subnet. No address space wasted beyond what is unavoidable. Here is an example. With fixed length, we are giving all of them 4 departments. If it is a class C, they're all getting 64, 64, 64. Whereas here in variable length, we are saying, wait a minute, we have our 4 departments, but here we have 55, maybe users. Let's give them. Here we have 30. Let's give them. Here we have 14. Let's give them. Here we have 5. Let's give them 8. As you can see here, we have minimized the wastage of those host addresses in those different networks that we have created. So as we do variable length subnet masking, same procedure like we used for fixed length, but here there's one golden rule that we must always follow. As we subnet, we should always first deal with the biggest or largest subnet first, then we work downwards till the smallest. Why does it matter? Because when you're allocating from the start of the address space in order, a larger network needs a larger aligned block. If you allocate a small subnet first, you may not have enough continuous space left for the large ones that come after it, leaving it awkward and unusable gaps. So that's why it is always, when they give you a number, when they give you a case, when you have a scenario for you to subnet, first identify the biggest ones and arrange them from the biggest to the smallest, and then from there you are able to as well go ahead and subnet. So if you have, like, for example, this, do not start from the smallest, all in whatever particular order that you may want. It's always advisable that you start from the largest to the smallest. Now, finding the right subnet size for each department. This is also something that is very important. If you have a network, for example, they are telling you here that we have this particular network, our first network, and there are 47 users currently in that department, and they tell you that you subnet. What you should do always, you ask yourself, under this network, where does it belong? how many host bits shall we need? Or how many host addresses do we need? Remember our formula, so we try the 2 to power n or h, where h represents the number of host bits minus 2. And here in this regard, 2 to power 5 minus 2, it's not going to work for us because we shall get 30, and 30 does not accommodate 47. So 2 to power 6 minus 2, we get 62, and so meaning the block size will be 64. So the 64 is what we shall take, and if we have 64 addresses, it means how many bits do we need to borrow from or how many host bits do we need to have? There are 6. If we have 6 host bits, it means we have given away 2, and we shall discuss that later shortly. Similarly, this applies to this as well. We look at the scenario. We need 30 addresses on this particular network. If we do 2 to power 4, it's not enough. If we do 2 to power 5, we shall get 30. Minus 2, we shall get 30, and yes, 30 can accommodate this because we are able to reserve the network address and the broadcast address. The same also applies to this network here. We have the one which is the one for 8 here. It doesn't fit in 8, so we're going to work it out together. So you always use the smallest n that works. So if n is exactly equal to the host needed, then that's fine. It is still enough. So that's what we are going to look at. So let us try out this number together, assuming you have been hired at Parliament, and Parliament they have given you this task as a junior or as a network engineer, and they ask you that they have network congestions, and the ICT committee has recommended that you do a full network redesign, and you have assessed the current network and you realize it's flat, inefficient, and need to do proper segmentation using variable length subnet masking, and they have given you this IP address of 192.168.50.0, which is having 24 network bits covering 4 priority offices. So in each of these departments here, we can see that we have the office of the speaker, which has 47 U computers or that need addresses. We have the department of the government chief whip, which is having 30 computers. We have the leader of opposition, who is having 8 computers. And we have the office of the clerk. Like we said, the rule of thumb is to first sort largest to the smallest. So we're going to sort them. Speaker's office needs 47, government chief whip 30, leaders of opposition 8, clerk needs 5, and then we start working it out. So let me get into my writing part where we are going to write. So this is what we had previously done. Let me just get rid of this. We shall be populating that table later on. So this is going to be the speaker's office. Under the speaker's office, we are going to have the other one, which was a government chief whip, and then we have the leader of opposition, and then we have the clerk to parliament's office. When I look at our requirements here, the speaker's office needs 47 hosts. So I'll come back here and we'll write them here. It needs 47. Let me remove the highlight here. It needs 47. And then the next one wanted 30. And then the leader of opposition only has 8 users. And the clerk to parliament has 5 users. All right, this is what is required. Remember, our rule of thumb is to first rearrange this in big to smallest. So we have done that already, and we have partly filled in our table. So the next thing we are going to do is to understand these particular networks and where it belongs. Now, as a good networking student, you should remember and have this at the back of your head, that for every network for every given network here in networking, all right, we can either have a network which is, let me just write it down here. We can have a network which can be in 128, our block size, all 64, all 32, all 16, all 8, all 4, all 2, all 1. And remember, this comes from our scale. Which scale are we talking about? Our scale of 2 to power. Remember, this is 2 to power 0, 2 to power 1, 2 to power 2, 2 to power 3, 2 to power 4, 2 to power 5, 2 to power 6, and 2 to power 7. All right? So, this is ideally what we have. This scale should always be at the back of your fingertips, always, as good network engineers. Now, we look at our first network that we need to subnet. Our first network here, the one for speaker, they want us to give it 47 users. Okay, they have 47 users, but we know we don't have a network which is exactly 47. So we look at our scale here and say, where is the perfect fit for those 47? I want you to first pause for a brief moment and tell me, do you think the 47 belong here? Can they fit in 16? No. Can they fit in 8? No. Can they fit in 32? No. Can they fit in 64? Yes. Can they fit in 128? Also yes. But where do you think do they perfectly fit? I think it perfectly fits here under 64. So that means that our block size for our given network, this one here, it is going to be under here of 64 because it's our perfect fit for 47. So meaning this network we are going to subnet, we are going to allocate it a total of 64 addresses. But keep in mind, part of this block size, we always reserve two networks. We always reserve the network address and the broadcast address. All right. So now, us having determined that it is 64, we look at our IP address, which was given to us, so that we perform the actual job that is before us. So let us look at the IP address. The IP address was, let me just get it here very fast. Our IP address was 192.168.50.0. All right. So let me come back here and we write it here. Right. So this was our original address that they have given us, which was 192.168.50.0. Now, before subnetting, this original IP address had a total, because it's class C, so 2 to power 8, we shall get a total of 256. So if you want to get the usable one, it will be 2 to power n minus 2, which will give us a total of 254. So the original one before subnetting had a total of 254 usable or valid host addresses. Our default subnet mask here, because it is class C and we have 24 network bits, it is going to be 255.255.255.0. That is our original subnet mask. It is important for you to always do that. The way we did in fixed length subnet masking. After understanding that, we can now come here for making it easy. Let me write the subnet mask in binary. So this is 1, 2, 3, 4, 5, 6, 7, 8 dot. Let me make the dot bigger. 1, 2, 3, 4, 5, 6, 7, 8 dot. 1, 2, 3, 4, 5, 6, 7, 8 dot. Let me just change the color and then write my host bits, which are always represented by ones. 1, 2, 3, 4, 5, 6, 7, 8. So we have our subnet mask there. So our first network address, which we have, I can even come and write it in directly. All right. So it is 192.168.50.0. It is our first network address. So I can even write it here, right? Which is, let me make my screen a bit bigger. So which is our original one is 192.168.50.0, isn't it? So now we have understood that this is going to fall in the block size of 64. So we ask ourselves, how many host bits must we have for us to have a total of 64 addresses? If you have this cascade, it is easy because you can already see here that 2 to power, let me just highlight, you can already see here that 2 to power 6, this 6 here, we shall get 64. So in other words, we need 2 to power 6 for us to be able to get 64 addresses. So meaning we need a total of 6 host bits. So this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. This is what we need for us to have a subnet which can accommodate 64. So meaning for us to create a subnet, for us to subnet, we need to borrow away these ones. So we are going to borrow these and we are going to give them away to the network portion. And how do we do that? We do that by changing them into ones. So we have given away this one, this one here, all right? So we have 2 of them which are given away. So initially before we had a total of 8 bits, 8 host bits. We only need 6. So if we need 6, we don't need the other 2. We give these leading bits to the network portion by converting them into ones. So our initial subnet mask had a total of 24 network bits. But now we have added 2 onto them. That means now we have a total of 26, because if you get 24, the ones we have here, 8 plus 8, 16 plus 8, that is 24, plus 2, that is 26. So this is our new prefix for this particular network which we have created. And this particular network which we have created has a total of 64 hosts addresses, isn't it? Meaning the next network will start immediately where this particular network has stopped. What is the next network? Let me even write it down for you to simplify. So our next network will be 192.168.50.64. Why? Because we are counting 64 addresses away from this. So this will range from 0 to 63. Why? Because if you count 0 and you also count 0 part of the family, we shall end at 63. And I'll show you how that comes about. So our network address will start from 64. So I come here and I fill in my table. Now that I know what is my new prefix, you can guess my new prefix, because we have borrowed 2 bits, it will be 26. All right. Sorry, this was supposed to be the subnet mask, so I'll write the subnet mask later. So our network address, the initial network address we started with, which is 192.168.50.0, isn't it? The first usable IP address, I'm not going to write this again, but it's supposed to be 192.168.50.1. All right. And then our next network address, now we have the next network address here, so we can easily write it, which is 192.168.50.64. 64 is our next network address. Let me try to just make my table a bit bigger. And let me wrap this away. Okay, good. So after wrapping that away, you can see that, let me write our original subnet mask here. Our original subnet mask was 255.255.255.0. That was our original subnet mask. Now, let me just rub my table to make it clean for you. Good. So now on my table here, on my table that I have, let me use a smaller. So my prefix currently is 26, right? Here, because I have borrowed 2 bits. And my network address was the first network address that we're dealing with, 192.168.50.0. It is my first network address. The first usable IP address is 192.168.50.1. We just add 1 from our network address. And then our next, because we are having a space of 64 addresses, our next will be an addition of 64 address from that. So it will be .50.64. 64 is our next one. So the first usable or the first valid here will be, guess what? .65. We shall just add 1 onto this, so we shall have .65. Please don't forget to write everything else, because if you just write .65, that is not a valid IP address. But just to, because I have small working space, I'll just write .65. And now the broadcast here is you get the next network address -1, or you can just count 64 addresses away from this. We shall end up at having 192.168.50.63, right? It is 63 because our next address starts at 64. So it just makes sense that this starts immediately where this one stopped. So our last usable, you just subtract 1 from our broadcast. So have you seen that the moment you have the network address, everything else becomes easy? Even when you have the broadcast address, the next one becomes easy. So this one will be .62 because I have subtracted 1 from 63. Now, that is easy peasy. It is sorted, right? Now, let me go to the next network of 30 and create the network. So I go back to my scale. This one is sorted. It is taken care of. So, and the speaker's office people will be happy. We have taken care of their needs. They have the IP address that is going to take care of their needs. So now we need to create another subnet that is going to accommodate for 30 hosts. All right, 30 hosts in the government chief whip's office. Oh wait, I didn't complete the subnet mask here. So to complete the subnet mask, it is very simple. We just convert this into decimal. Initially, allow me to wrap this. Initially, it was 255.255.255.0, but now we have 2 new network bits added onto them, right? So here it will be 255.255.255. It's no longer 0. Why? Because we have 2 new network bits. This one on our scale, remember, it represents what? 128. This one on our scale represents 64. That's why I say that scale is important. So the rest are not turned on. This one represents 32 all the way up to 1, but it is not turned on. So we shall only just add these 2. And once you add 128 plus 64, you are going to get 192. So the new subnet mask for our speaker's office is going to be 255.255.255.192, and you have your network done. So we continue and go to the government chief whip. The government chief whip here is asking us for 30. Let me just get rid of that. Is asking us for 30 users. So we ask ourselves, why do you think 30 will perfectly fit? Do you think 30 will fit in 16 or 8? No. Do you think 30 can fit in 32? Yes. Do you think it can also fit in 64? But it perfectly fits in 32 because we even have the 2 reserved addresses, the network address and broadcast address. You must always accommodate for them. You must always take care of them. So meaning 30 is going to be under 32. All right. So our block size is 32. Now, meaning this network we're going to create for government chief whip, or the subnet we're going to create for government chief whip, will have a total of 32 addresses. So now I come back here and say, how many host bits do we need for us to create 32 host addresses? And you can see the power 5 is already there, so no rocket science. But currently we have, how many do we have? You remember, not 8, we have 6, because you already gave away 2. You can't have what you gave away already. So we have 6. That means you're going to get 1, 2, 3, 4, 5. This is what we need for us to create a network with 32 block size. So this we are going to give away here, and it's going to be this here. We have given it away, and now we are having 5 host bits. So after giving it away, how many network bits do we have for us to get the prefix? When you count in total, 8 plus 8, that is 16, plus 8, 24, plus 3, 1, 2, 3, that will be 27. So our new prefix here, members, is going to be /, let me use a blue pen. Sorry, I wanted to use a blue. Where's draw? Yes. So our new prefix here is going to be /27, because we have added one more that we have borrowed. We can even get the subnet mask here already. Here we added 128 plus 64 plus now 32. So we can get our calculator. Let me get my calculator here on the computer. Bring it up. Get 128. We add on 64. We add on 32. So our new subnet mask will be 224, right, for this network. So let me get this here. Rub this away and come back here, and then it will be .224. So I come on my table and I write my subnet mask. So it is 255.255.255.224 with a prefix of 27. My network address, we had it already, which is 192.168.50.64. Immediately where this one stopped at 63. So this one stops at 64. So what I usually do, because I know the size already, all right, my network address for the current network is 168.50.64. Because I know the size already, what I do, I just add that block size onto this to get the next network address. It is important because once I get the next network address, it's easy for me to get the broadcast. It is easy for me to get the other details. So here, if I add, this is 6 and this is going to be 96. Correct? So this is 8. Yes, this is 6. So it's going to be a total of 96. So I'm going to come back here and write my next. Let me write it in a different color so that it doesn't confuse us. So let me come here. I use green. So I write my next network address, which is going to be 192.168.50.96. Now, once I have my next network address, the rest is simple. So we said here, first valid, we just add 1. So this will be 192.168.50.65. This one will get this one minus 1, the next one minus 1. So it will be 192.168.50. Guess what? 95. This one will subtract 1 from the broadcast, so it will be .94. As simple as that. But please ensure you write the full IP address. So that one is done also. We tell the government chief whip that please don't look for us anymore. We have taken care of you. Right? So let me just highlight this with the color to just show that these ones are done. All right? So done. Now, we have 2 more left. But these 2 more, we already figured out the first network address for the leader of opposition. It will start at .96. It will be our network address for this one. But we need to find out the block size. Here, they are showing us that it only has 8 users. So we need to create a network that can accommodate 8 users. Now we come back to our scale. Where does 8 fit? Does it fit in 4? No. Does it fit in 16? No. So yes, it fits in 16. Does it fit in 8? Yes. But remember, we are looking for 8 addresses. But the block size of 8 itself will not be sufficient. Why? Because if you give it 8, remember you need to subtract off 2. You need to get off the network address, you need to get off the broadcast, which you won't give. That means you will only be able to give 6 addresses to the people in leader of opposition, and 2 of them will be left out, which is not good. So for you to accommodate all of them, much as 8 perfectly fits in 8, but it is not enough if you consider the network address and the broadcast address. So that means I need to go to the next accommodative block size, which is 16. And I again ask myself, how many host bits do I need for me to create a subnet which is having a total of 16? And in this case, we are having 4. You remember this scale. If you have this scale, you don't even have to scratch your head. First write it down, and then every answer you'll be asking yourself is there. So we need 4 host bits. For now, we have 1, 2, 3, 4, 5. So all the 5 will not be needed. So I will come here, get my and then get rid of one of them. So I'm going to come here and borrow this away. So it will be now our new subnet mask. So our new subnet mask is having how many? We are adding now 16. We is having how many network bits? 8, 16, 24. Now 24, you're going to add 1, 2, 3, 4. 24 plus 24, you get a total of 28. Very good. So that means, let me change the color to green. That means that our new prefix here is going to be /28, because 24 plus 4, you get 28. What will be our subnet mask? Get my calculator. Add 222 plus, I add 128 plus 64 plus 32 plus 16. And then I will have my new subnet mask in decimal. So my subnet mask will be 255.255. What was our answer? Our answer was 240. So this will be .240. Alright? And now I have the subnet mask, I have the prefix, I have the network address. It is easy for me to get the first valid. The first valid here will be come on, tell me, 97. Very good. Now, for me to get the broadcast, I will know this is having a total of 16, isn't it? This address that we have created is having a total of 16. Let me first get rid of this here very fast. So our current network address we are working with, for us to get the next address, is what? Is 192, if you may remember, is 192.168.50.96. all right? So let me just write it down here, which is 192.168.50.96. So for me to get the next network address, I'm going to just add 16 onto this. So 96 plus 16, get my calculator here, 96 plus 16, I'm going to get 112. So my next network address is going to be 112. So I can come here and write it. So let me just use a different color. What one can I use now? Orange. So my next one will be 192.168.50.112. all right, that will be my next network address. Now the reason why I get it, because it is easy for me to just get here the broadcast. The broadcast here will be .111, because I subtract 1 from this one, and then the last valid here will be .110. As simple as that. I am done with my table. Now once I have this here, I need to just come and also calculate. This one is also done. Understood? So we are on the last one now, which is the clerk's office. Clerk office needs only has only 5 users. So we ask ourselves, where does 5 belong? In 4, no, it can't fit. In 8, yes, it perfectly fits. And then we are going to use 8. So here it means we only need 3 host bits available. At the moment we have 1, 2, 3, 4. Right? So we need to give away one of these. So I'm going to give away one of that. And then allocate this to the network portion. So if I allocate this to the network portion, our block size has changed from 24. Now we have 25, 26, 27, 28, 29. So our prefix here will be dot 29. What will be our subnet mask? We can just add 8 onto that, right? Because we have added a bit which represents 8. So I have 240 plus I have we have added there 8, right? Because this one represents 8, isn't it, members? The one for 3, it represents 8. So we're going to add 8 onto that. So I got to add 8, and then I'll have a total of 240. So it will be 255.55.2 .248 is our new subnet mask in decimal. Now, what is our next valid here? It is very simple. My next valid here is .113. What is my broadcast? I count 8 away from this, right? If you count 8 away from this, the easiest I do it, I just come here and I add 8 onto this so that I get the next network address. So this will be 10, carry 1. This will be 20. So I'll have carry 1, this is 2, so it will be 120, isn't it? So my next network address will be 120. If it is 120, I subtract 1. So here I will have dot 119. And if you add 8 onto indeed this, you'll get 119. And then my last valid will be 118. And your table is done. You have all your workings done. You get your network addressing. You either carry it into packet tracer if they have asked you to implement it in packet tracer, or you just go ahead and implement it physically, depending on what you want to achieve. So basically, this is what we do in a variable length. Sorry, the video is a bit longer, but I had to find a way of explaining all these steps that we have done so that we create these different block sizes that you see here at the end of the day. All right. So this is what basically we have done. Allocate the large network first, give it its network, find a network address, and then also allocate it as well. All right. And then you are able to succeed in whatever that you will be doing until when you complete all of the networks. And this is the table that we have at the moment. It's a table that we have got, but as you're writing it, please ensure you don't write dot dot. Here I wrote dot dot because the space is not enough, but these are the calculations that we made. You saw how we made them and we arrived at this. So we still have one from 120, the next network address, to .255. All of these are free, and we can later on, if maybe another office comes, we can later on use them to subnet and create another network in that regard. So what we can take away from this particular is that VLSM means Variable Length Subnet Masking, and each subnet gets a different size. All right, it avoids wastage of addresses. It gives the department exactly what it needs. The rule is first sort the biggest one before you go to the smallest. And as you're getting the block size, always ensure that you have accommodated for the 2 addresses, the network address and the broadcast address. Always, it should always be taken into account. You should always think about it in that regard. And also the allocation, when you start from 0, the previous one, so you need to keep going like that. The broadcast address, you can always think about it. You can always convert from binary to decimal, but basically that is what variable length subnet masking is all about. So thank you so much for listening to me, and have yourself a good time.